right, hello again, Honors Integrated 2. Today we are talking about the thrown object or projectile motion model. That's what that says right there. And this is truly physics. I've talked to you many times about why we do these things. Well, it's physics, and there are lots of thrown objects that you could deal with. You know, a baseball, a football, or like a Nerf rocket, or a golf ball, or anything that's being thrown, really. And this is the model right here. And you've actually worked with this before. And a couple of things to look at is, of course, since the degree is 2, then you know it's quadratic. And as soon as you know it's quadratic, well, that brings up everything we've done. That brings up the quadratic formula and factoring and square roots and just everything we've done with quadratics, including graphing. This is it, right? This models everything. And so there's some things here that you should be familiar with, like h of t. H of t is the height at a given time, or the time at a given height. You can kind of look at it both ways, but height at a given time. What's this right here? This is due to gravity. That -16, that's the acceleration due to gravity, but that's in feet per second squared. That can change sometimes. Instead of -16, sometimes it's -9.8. But that's when we are measuring in meters per second squared. So in our case, everything we're going to do in this class is going to be dealing with feet per second. So you won't see this much until you get into physics. For now, we're going to stick with that -16 right there, and that feet per second. What is this V sub 0? We actually call it V sub naught. That's how you say that, sub naught. I know that seems kind of strange, but that 0 is initial. This is the initial velocity. In other words, how fast it's going right from the start. Like if you were to hit a baseball with a baseball bat, that V sub naught, that initial velocity, would be the speed it's going, the ball is going, as soon as it leaves the bat. By the way, if it's going up, then it's positive. If it's going down, it's negative. So that's by definition. We're saying if it's going away from the Earth, then it's positive. If you're throwing it down towards the Earth, then it's negative, which also explains why that 16 is negative, because the effective gravity pulls stuff towards the Earth. That would be in a negative direction. That's by definition. We say if something's going away from the Earth or up, that's positive. If something's going towards the Earth, that's negative, and we defined that a long time ago. So, and then what's the last thing? The last thing is this S. This is not a 5. It is an S, and it is the initial height. Initial height. And that's in feet. Right? And it has to be in feet because we have to keep all of our units the same. I've already said the gravity is feet per second squared. This is going to be feet. What is the initial velocity? What are the units of that? Velocity is in feet per second, not feet per second squared like the acceleration. Acceleration is squared, velocity is not. That's a physics idea. So for now, anyway, this is our thrown object or projectile motion model. So to quick review, it is quadratic because of the 2. This is the height at a given time. This is a function. The height depends on the time. -16 is gravity. Sometimes you see -9.8, but not in this chapter and probably not in this class. V sub naught, or that's the initial velocity, and N is the initial height. Let's see about an example. Okay, so here's our example, and you probably want to write it down in your notes. A golf ball is hit from a 10-foot tall elevated driving range with an initial upward velocity of 65 feet per second. How long will it be in the air? So, I know you love my drawings. This is going to be an issue of an X and Y axis like this, except this is going to be time, this is going to be height, and you've got this elevated driving range. So someone is sitting right here with these thick markers. It's hard to draw. And anyway, he hits a golf ball. Here's the golf ball, and it sails like this, bam, like that. And so, I don't think that was on video. I think I fixed it now. Anyway, you have the x-axis, which is t, the y-axis, which is 8. You got a guy right there who just hit a golf ball. I'm not even going to try to show that. And the question is, how long will it be in the air? How long will it be in the air? Well, it's in the air until it hits the ground, effectively, which is right there, which is when the height equals 0. So we are really interested in the time when the height equals 0. Now, just so you know, this parabola extends down here and it'll cross here. So the intercepts, will have 2 of them. One will be positive, one will be negative. Clearly, if this x-axis is time, you can't have a negative time. So we're just going to disregard that solution and we're going to take this answer here. So this is the situation. And then of course I have this problem written down up here. Let's identify some stuff. It says a golf ball is hit from a 10-foot tall elevated driving range. This is where the golf ball starts. That makes that S. That is the initial height. Elevated driving range with an initial upward. Since it's going up, that means it's positive. Velocity of 65 feet. That makes this the V sub naught. Here's your initial velocity. You know it's positive because it's going up, and I have an initial height of 10. How long will it be in the air? And that's when we know h of t has to be 0. I'm going to take this information here and I'm going to input it into the model. Okay, so I'm going to take this information, like I just said, and input it into this model here. I have the S, which is 10 feet. That's the initial height. That's going to go there. I've got this 65, which is the initial velocity. That's going to go there. And then how long will it be in the air? I need that h of t to be 0, the height at a given time, or the time at a given height. I'm interested in what's the time when the height is 0. So if I plug that into this equation, here's what I get. Negative 16 t squared plus 65 t plus 10. And as you can see, I now have a quadratic equation that I need to solve. And it equals 0 already. That's good. But now this brings up what we did yesterday. What method do you choose? And that's why we did that stuff yesterday, so that you kind of get used to, choosing a method and being mathematically agile. Which one do you choose? So I break it down. Well, can I take a square root? Can I just solve by taking square roots? Unfortunately, because of that, I can't take a square root. That's going to mess me up. Can I factor it? Oh man, I don't really know. It kind of looks kind of complicated to factor. It doesn't look like it's easy. I don't know how I'm going to get a 65 with yeah. I just don't think that's going to happen. Maybe it is. I don't know. But I know the quadratic formula is going to work. So you know what I'm going to do? I'm going to use that. It's going to be x equals negative b, which is 65, plus or minus the square root of b squared, that's 65 squared, minus 4 times a, which is negative 16, times c, which is 10, everything over 2 times negative 16. Tell you what, this quadratic formula is very powerful. It works all the time. And now I want to keep in mind that since we're being asked about how long it will be in the air, I really want my answer to be a decimal. I don't want to be 4 radical 5, what kind of an answer is that? How many seconds is that exactly? So what I'm going to do is I'm going to deal with this right here. So I'm going to simplify it and I'll turn it into a decimal. That's what I'm trying to say. Plus or minus, this ends up being the square root of, what is that? Hang on one second. There we go. That's 4865, everything over negative 32. So that's pretty good. I just simplified this here. I forgot a decimal place. Someone needs to double check me if I made a mistake. I'm sure I'll get some text. And now I need to turn this into a better answer. 1 second and I'll come right back. Okay, so I made some room so I can work with this and simplify it. So this is what I ended up with. The square root of that 4865, let's see, that's negative 65 plus or minus. This is about 69.7. I'm rounding to the nearest tenths place because when we're talking about seconds, how do we get really much better than the tenth of a second, at least for these estimations? Now, and this is where this idea comes into mind right here, back with this and this picture. I need to get two answers. One's going to be positive, one's going to be negative, and this is where it comes from. I'm going to break it up using this plus or minus thing right here. So what that gives me is this. I get x equals negative 65. I'll start with the plus 69.7 over negative 32. But then I also have this. I have x equals negative 65 minus 69.7 over negative 32. Can anybody just look at this and tell me which answer I'll probably end up taking? Which one's going to be a positive and which one's going to be negative? If you're looking at that for a second, you might be able to see that this is going to give us a positive because I got negatives here divided by negative. This whole thing is going to be positive. It looks like the top of this will be positive. That's negative. This is going to give me a negative. So I'm going to do all this. And if I just plug this into my calculator, then here's what I end up with. I end up with x equals negative 0.15 seconds. And then on this blue one, what I end up with is x equals 4.2 seconds. So which answer is the one that I want? Well, as I said before, I can't have the negative answer. That's not what I want. This must be the answer. And I say it's x. That's just out of habit. You know, x equals. I guess this should have been t, shouldn't it? I could have started up here with t as well, because that's really what I'm looking for. But nonetheless, just out of habit. So the time is 4.2 seconds. Back to our example right here. This right here is going to be 4.2 seconds, and that is when it hits the ground. This was that negative 0.15, but again, I can't have a negative time, so that's kind of unnecessary and doesn't make sense. So there you go. There's my example. Today's homework has more choosing your method. When you get into the word problems, honestly, just use the quadratic formula, unless you can factor it really quickly. That's possible, but anyway, there you go. We're going to talk a little bit about something called the falling object model soon, but for now, that's that. All right, text me with questions. Visit me during my office hours. Hope you're doing good. We'll talk to you guys later.